Hi, so this is just the video of the new stuff that we did on November the 11th. Sorry, I have stuff already written down over here. But essentially, the first question that we did was a review of empirical formula calculations. If you have doubts about this, view my empirical formula video. Basically, we take the elements. These are the molar masses of the elements from periodic table. These are the masses in 100 grams, which just correspond to the numbers over here. We calculate number of moles by doing mass divided by molar mass. And then we take all these three numbers and we divide each of them by the lowest one in this group. So the lowest one, if that was 0.38, we do all these numbers divided by 0.38 to get the lowest ratio or lowest terms, and those will form the subscripts of our elements. But what we can say about the molecular mass is the molecular mass will always be a multiple of the empirical formula mass, or empirical mass as a whole. What that means is if you take H2O and you weigh it, and let's say that's 18 grams, for example, H4O2, which is, note, double of this, so this 2 and 1, we have made a 4 and 2, will weigh 36 grams. And this is exact because you're taking H2O and you're adding one more H2O, so to speak. So you're doubling the entire mass. Similarly, H6O3 will always be 54 grams. There's just one of these times 3. So the actual mass, 18, 36, 54, 54 and 36 will always be multiples of 18 grams. Right? And that's how you figure out what the actual subscripts are, because we talked about how all of these things have the same percent composition. So for example, if the answer here was K2Cr2O7, we don't actually know if it's K2Cr2O7 or something like K4Cr4O14. It could actually be this, the actual molecule, but we don't know just based on the percents. We need to be given the actual molecular mass. So just a quick example as to how that would work in practice. We do the same empirical formula calculation as before. So for example, if we just take the formula of water, we have oxygen and hydrogen. The mass in 100 grams would be 88.8. This would be 11.2. The number of moles essentially would be, we're actually going to change up our example because we already talked about H2O. Instead, we're going to do oxygen and nitrogen, where I will give you the percent composition of oxygen and nitrogen, which is actually oxygen is 9.6%, and nitrogen would then be 30.4%. We calculated the number of moles by doing 69.6 divided by 16, which is 4.35, and then 30.4 divided by 15, which is 2.17. And I know I've written percent here. That's just because these are actually what are grams. Right? I will just give you the percents in the question. You're just going to write the same numbers in grams. And we know that this is a mole ratio. So again, number of moles, we're going to divide by the lowest number that is here, which is 2.17 among these two numbers. The lowest one is 2.17. So we divide everything by 2.17. and so we have this mole ratio, and so we have our empirical formula as NO2. So now, if I give you, for example, the molecular mass of this compound is actually 230 grams per mole. Let's say I give that to you. That will be in the question. Now, your empirical formula mass is calculated just like you calculate molecular mass for the empirical formula, right? So you take NO2 and you're saying, okay, nitrogen is 14.01 from periodic table plus 2 times 16.00, which is the oxygen from the periodic table is 16. So if I do that calculation, I get 46.01. Right? So now my molecular, how do I calculate my molecular formula from here? So I know that my molecular mass is a multiple of my empirical formula mass. I have to figure out how many times. So 230 divided by 46.01, which is approximately 5, 4.99. We're going to round that to 5. So my molecular mass, or my molecular formula, will be 5 times as heavy as NO2, right? So we're just going to take NO2 and multiply that subscripts by 5, and we're going to get N5O10, which is our molecular mass over here. All right, so we will go over this again in class, and I'll see you there.